everybody, this is JB. Welcome back. This is my Azure DNS Basics Lab. This is part 2 in my Azure Networking for Beginners Lab series. In this video, we'll be taking a hands-on approach to learning about the basics of DNS within an Azure environment. We'll be setting up a lab based on our previous VNet lab that we did in the last video, and we'll look at a few different types of DNS configurations that we can do to understand some of the basics of the features of DNS within an Azure environment. Azure DNS allows you to host your DNS domain within Azure. And there's a few different options that we're going to go through as far as different ways that this can be implemented. We're going to do a quick breakdown of some of the core concepts behind this, and then we're going to look at creating a DNS zone in Azure, a domain to go along with that. Then we'll look at different ways to integrate Azure DNS with different types of Azure services like VNets. Lastly, we're going to use a little bit of some PowerShell magic, spin up a couple of VMs in the different VNets that we have and see if they're able to resolve each other. Throughout this video, we're going to be using real-world examples that you can follow along in your own lab. By the end of this video, you're going to have a solid understanding of the basic concepts behind Azure DNS. So this video is perfect for beginners or folks who have a little bit more experience but just need a nice refresher on Azure DNS. Beginner or advanced, there's a little bit of everything in this video. So go grab a drink, sit back, hop into your Azure console, and we're going to dive into this and start looking at some of the basics of Azure DNS. All right, so right off the top, we're back at the AZ700 course. Again, there's going to be a link in the video description for this for you to follow along in. This is what we started covering in the last video. We looked at Azure VNETs and how to go about configuring those. You should still have those configured within your environment because we're going to need those for the lab today. So just to do a quick breakdown of some of the key concepts behind Azure DNS, we're going to hop in here and look at design name resolution for your virtual network. If you aren't familiar with DNS, really it's what allows all the different devices on the internet to communicate with each other by their domain names. So instead of devices communicating by IP address, we're able to use a domain name, which is much more user-friendly and easier to remember. So that type of communication requires some type of service to do a mapping between the IP address and the domain name, much like a phone book. So that's what we're going to be talking about today, is how to do this within Azure. So they have a few different options as far as what's available. They have a public DNS service, and this is going to be for any types of domain names that are going to be publicly accessible over the internet. So if you think about company websites that you go to, that would be a public domain name. So if we were to go to like ESPN.com or tryhackme.com or Google.com, those are all public domain names. Within Azure, they're able to do a few different types of records to be able to support this type of communication. We have host records. This is going to be what they either call a single A or quad A, depending upon whether or not we're using an IPv4 address or IPv6 address. They also have something known as alias records, which go back to a canonical name or CNAME. So some things that we want to consider when using this: the name of the zone must be unique within the resource group that we're creating. So when we have a particular domain, what we need to initially create is a DNS zone for the hosts within that domain. So before we actually go about configuring things on clients, we actually need to set up that zone within Azure, and then we can create the individual records within that zone. So just some basic considerations that we need to be aware of when using public DNS zones within Azure. The name of the zone must be unique within the resource group, and the zone must not already exist someplace else. The same zone name can be reused in different resource groups or a different Azure subscription. Where multiple zones share the same name, each instance is assigned different name server addresses. When you go to configure these particular domains out on the internet to be accessible, the root parent domain is registered with the domain registrar. So that would be where you actually get that name from, which could be Azure, it could be AWS, it could be some well-known domain name registries. And then within that configuration, it points back to the Azure name servers. Child domains are registered within Azure DNS directly. And they mention here, you don't actually need to own the domain name to create a DNS zone with the domain name in Azure DNS. However, you do need to own the domain to configure that domain. There's a few things here where we could actually delegate the domain so that Azure is actually controlling that. It goes a little bit into delegating DNS domains and child domains. You can read through this. This isn't actually what we're going to be looking at today. What we're actually going to be looking at is a private DNS service. So these are things that aren't accessible over the internet. So it's private within your particular Azure resource groups. And then also if you have any connections back to, let's say, a hybrid network or your on-prem equipment, there's some configurations that we can do to make sure that your servers or devices within that environment are able to use or connect to that domain within the Azure cloud. So they talk about a few different options that we have when resources are deployed within VNets and we need to resolve domain names to internal IP addresses. We have a few different things. We use Azure DNS private zones. We could talk about the Azure provided DNS resolution. And then we also could use name resolution that uses our own DNS servers. What you end up choosing out of these three depends upon what you're actually trying to do. If you need to communicate just within that particular VNet and not externally, then the Azure provided name resolution might work for you. If you need to communicate between multiple VNets, then you're going to want to use their private zones. If you want to have that communication available from your on-prem environment into the cloud environment, then that's going to be when you're going to need to use your own DNS servers. So DNS servers within a virtual network can forward DNS queries to the recursive resolvers that actually exist within Azure. So what this does is it allows you to resolve host names within the virtual network. So for example, if we have a domain controller in Azure, that can respond to DNS queries for its domains and forward all those queries onto Azure. Forwarding queries allows your VMs to see both your on-premise and Azure provided host names. This is an IP address that you'll see quite a bit. So access to the recursive resolvers in Azure is provided by the virtual IP 168.63.129.16. They're using Anycast here. So this isn't a particular server. This is just an IP address, and whichever the closest DNS server to this is able to resolve, then that's what you're going to get. So let's talk about the default DNS options that you have with your Azure provided DNS. This is internal DNS. We talked about the particular IP addresses that end up getting assigned to this out of the overall subnet. Whenever you create a VNet, it's going to create its own internal DNS zone. It's going to support automatic registration, so that means that you don't need to create host records for whatever devices you end up spinning up. And all this is done automatically whenever you create the VNet. It's also a free service. There isn't any other cost associated with this. Whenever you go this option, it is going to be completely automated. You aren't going to need to do anything for that. The downside of that is that there's no manual configuration that you're allowed to do, and Azure controls the DNS zone names and the lifecycle of the DNS records. As I mentioned here, it is important to recognize that the Azure resource name is what actually gets registered and not the name of the guest OS on the VM. There are some limitations to this, and it doesn't scale, so it can't resolve across different VNets. It registers resource names and not guest OS names, as I mentioned, and doesn't allow us to do any type of manual creation. So this isn't necessarily something that is going to be really workable in a lot of situations unless you just have a single VNet and it doesn't have any type of external access to it that needs to be doing any type of domain resolution. Now, the third and last option is what we're going to be doing in the lab today, and that is Azure Private DNS zones. So these are available to internal resources only. They are global in scope, so you can access them from any region, any subscription, any VNet, any tenant. The only thing is you do need to have permissions to read the zone. So things that we would be doing that, we configure a DNS name for a zone, create the records manually, resolve names and IP addresses across different zones, and resolve names and IP addresses across different VNets. So the second thing that we're going to be doing once we actually create this private zone is we're going to be linking it to the VNets that we already have in our lab environment. The default configuration as part of DHCP assignments is going to have the devices pointing to 168.63.129.16, as I mentioned above, to use the Azure DNS service. So there's a few different ways that we can actually link the VNets to this private zone registration. Each VNet can be linked to one private DNS zone. It is worth noting that up to 100 VNets can link to the same private DNS zone for registration. So the other way that we can link a VNet to a private zone other than registration is resolution. And with that, we can have many other private DNS zones for different namespaces. So we can link a VNet to each of these zones for name resolution, meaning we can go and we can look up domain names within those particular zones. So each VNet actually can link up to 1,000 private DNS zones for name resolution. And that allows us to be able to do resolution across all those different VNets that might be outside of what we control. And one of the last thing that I should bring up here, and I kind of mentioned up above, is whenever we want to integrate with a hybrid solution or on-prem, there's a little extra step we need to go through to make sure that our on-prem environment is able to query stuff within our Azure environment. And here, this diagram kind of walks through what we have to do. as far as on-premise DNS needs to have a conditional forward to queries to VNet, whatever VNet we want to communicate to. Within that VNet, there's going to be a DNS resolver, a VM that we're going to have to spin up, and then that would actually point towards the Azure DNS Anycast IP and would allow and support our on-premise environment querying the different domains that VNet1 would be able to resolve to. And the main reason that we have to do this is because if our DNS server is outside of the Azure cloud, they aren't actually able to access the Anycast IP address, which is why we then have to create another DNS server within the Azure environment that is able to do those lookups and make sure that our on-prem server is able to send queries to that particular resolver within our VNet. All right, so that was quite a bit of stuff. Let's get our hands dirty, actually get in this lab and start configuring some things. All right, so in this example, we obviously need to have the same environment that we already had spun up. We have the resource group, we have 3 different VNets, and we have subnets within each of those VNets. If you haven't gone through that, go back and check out Lab 1. I'll have a link in this video description for a playlist of all the labs, so you can go back and easily find that. So what are we going to be doing in this particular exercise scenario? We're going to configure DNS resolution for the company. So we're going to create a private DNS zone. You can name this whatever you want it to be. Link the VNets for registration and resolution, and then create 2 virtual machines and test the configuration. Cool thing with doing the virtual machines today, if you haven't had any PowerShell experience before, we're going to be doing a very, very small amount of that, but hey, it's always good to start to build up some skills in that way. But everything in here is laid out very easily, so it should be an easy win as far as doing a little PowerShell and some JSON configuration files. So let's see. So we're going to create the private zone first. Then we're going to link the subnet for auto registration, create the virtual machines, and then verify the records are present in the DNS zone. So we're going to hop into the portal. Once we're there, we're going to enter DNS and select private DNS zones. Once we select private DNS zones, we're going to create, and then we're going to use the following information here to fill that out. So the resource group that we already created, and then the domain name, and then we're going to go review and create. So we can just go up here, DNS, private zone. Don't have anything, we're going to create one. All right, so we're going to make sure that we have the right subscription. We're going to go make sure we have the right resource group that we created before. I'm going to go CyberInsightLab.com. Resource group, it's going to default to US East. And then it says we can link virtual networks to this private DNS zone after it's been created. That's exactly what we're going to do. So let's go review and create. Again, remember, this is a private DNS zone. This isn't going to be a domain that is accessible over the internet. And we're going to go create. We see here that the deployment is in progress. So one thing I do want to bring up, we do like to talk about pricing to make sure we understand what we're getting into here. If we go and look at this Azure DNS pricing, if you're using that free account, then this shouldn't be bothering you because of the fact that you have the $200 credits for the month. But if you didn't have that, then what we have here is the first 25 hosted DNS zones, 50 cents per zone per month. Then you start hitting also numbers on queries. Shouldn't really be running into that. This shouldn't be an issue for us. But did want to bring it up so that you could see. Okay, so our deployment is complete. So let's go to the resource and take a look. And CyberInsight Lab. See anything else kind of interesting here? Activity log, nothing there. Virtual network links is what we're going to be looking at here next, I believe. So underneath that, we're going to take a look at task 2, link subnet for auto registration. So in our domain that we created, under settings, select virtual network links. And then under that, we're going to click on this add. And then we are going to link these following virtual networks, these following VNets. So We're going to do core services VNet link. No changes required. We're going to select the particular VNet, and then we're going to make sure that we do auto registration. So what that means is whenever we have any hosts that are created, we're going to have domain names automatically created for these hosts. And then after we do that, then we're going to go through and do this for the other two VNets. So we'll just go virtual network links, add, link name. If we knew the resource ID, we could put that in here. If we don't know that, then we're just going to use this click down here. So this is the core services network, and we want to enable auto registration. And we see up in the top right hand corner, it says creating virtual network link. And we see link status completed. Okay, so now we can take the information from the other two VNets and we can do that. So I'm going to power through this, speed up the video, and you can go ahead and do the same thing. All right, now we come back and we see that all three of these virtual network links have been created. All three of these VNets are now linked back to the CyberInsight lab.com private DNS domain. All right, so for task 3, we're going to create some virtual machines. This is where some automation scripting comes in and is really, really helpful. We're going to be using PowerShell to do this and upload some JSON files. So I'm going to show you how to go ahead and upload those. The files themselves, if you go and click on this link, it's going to take you to GitHub, and you're going to see what these are. So we can take a look and see what these look like. So let's go back here. The files that we really care about underneath here is the Azure deploy.json and the Azure deploy.parameters.json. Now, you can modify some of these things in these parameters file if you want to, but if you just take these two files and use these the way that I'm going to show you, then this lab will work perfectly fine for you. Just to give you kind of a quick breakdown of what's actually in these scripts, there's a whole bunch of parameters that are identified as far as the VMs, the nicknames, and the size of the VMs, and admin username and admin password. Then we get into some other variables that are going to be going along with the resources that we're creating. In essence, we're creating two different VMs. Underneath that, there's going to be a computer name, a username, and a password. We also identified the VM size, the particular image that's used here. And here we're going underneath the NIC that we mentioned creating above, setting some configurations here, specifically IP address, looking at a public IP address for this so that we're able to actually get in and remotely manage it. And the network security group, which will protect the traffic. Think of it kind of as a bi-directional firewall that is applied at the network level. And then the network security group, which in essence is bidirectional ACLs, and you can apply that within the network or at the interface level. We're going to actually do a few labs on these much more in depth a little bit later at the course, but just trust that what we have within this configuration for the network security groups is going to work fine and be attached to the primary NIC. What you see here is it's going to be allowing TCP 3389 inbound. If you want to lock this down a little bit more, this source address prefix here is any. So that would mean anything from the internet could be able to get into this. There is a username and password, obviously, that we're going to be using. But if you want to lock this down, you could put in the /32 of your public IP address for your home internet connection if you wanted to be a little bit more security conscious here. And then we're getting the same thing, VM number 2, NIC number 2, another network security group attached to that particular host. And then we get into the public IP configuration here. All right, now as far as the other file here, we're looking at the parameters file. These are pretty much being fed into this other script. It's what it's referencing back to. So VM name, test VM1, nickname for VM1 is test VM nick1 or test VM1 hyphen nick. Same thing here, the VM size. So this is the standard Test user is going to be the username, and then test password is going to be the password to be able to RDP into this box. Again, we want to look at the pricing that comes with something like this. If we were to run these VMs for the whole month, then it'd be about $53. Again, we're going to be running these for a few minutes, so you shouldn't really see too much of a cost that comes with this. Again, if you're using your $200 credit, then this will be negligible. You see here, this is kind of like the lowest price within this group of virtual servers. So we have both of the files. To end up using those, what you're going to want to do from GitHub, go click on raw under each of these different pages. You're going to get this like this. Then you can go and you can save this to your desktop. Make sure that you are saving this as a .json file, because that is the format that's going to be needed to be uploaded. So as far as the particular commands that we need here, we have this variable. Make sure that whatever you have in here is going to be the name of the resource group that you created. You can set this here as a variable so you can reuse it. If you didn't want to do that, then you don't need to put that, and you could just type in whatever the particular resource group is that you're creating here. The rest of this, we're going to leave it alone. Do that. So let's go upload those files into PowerShell, and I'll show you how to get into that console here from within the Azure portal. So if we go up to the right top here, there's this little cloud shell, and we're going to hit on that. We're going to give that a minute to populate. Okay, so we are here now. And if we want to upload files into this, we can look and see. I should have some stuff in here already from stuff I've done previously. If we go ls, we can see, yeah, I got a whole bunch of stuff from the other labs that I've done, but that's okay. We're going to overwrite that. So we can go see these buttons up here. We have different options: upload, download files, open new session. So let's just go upload, download. So we're going to upload, and we can see that we uploaded that there, the Azure deploy parameters. Now let's upload the other one. All right, and we see that the Azure deploy was uploaded as well. If we do a ls.al or ls space hyphen al, we can see the dates uploaded here. And we can see that these dates for these files I just put up here are for January 16th and January 16th. So we should be good with that. Apologize if like the output on that screen is a little funky. I typed in a clear on that, and hopefully that makes things look better. There we go. Okay. Now, so we've uploaded those. We should be good. Now we can go back and look at those commands over here. I'll just move this over. Now the group that we created is CyberInsight Lab on here. So you put in whatever the resource group is that you created. And then I can copy this one over. And we're going to hit enter. And what that's going to do is we're doing a deployment with these JSON files within this resource group. So we're just going to wait for this to go, and I'll come back once this is done. We see here this completed, deployment name, resource name, succeeded, things that we did, created these VMs, created these NICs, standard size, test user, and then the password that we had. So if we go back to home and kind of minimize this for a second, and we go to resource groups, if we go under here, go into the CyberInsight Lab, we should see a whole bunch of different things created here. So we can see the private domain name that we created. We can see the test VMs. So if we kind of click into these a little bit, we'll just poke around so you can see what we have going on in here. Windows server, we see that it got a private IP address and a public IP address. We see that the size matched what we had in the parameters file. Some other things we could dig down into this if we wanted to actually mess with this. Anyways, we could do that. We have options here which we're going to use. We're going to use RDP to connect into that. And we can, just like if you've ever done anything in AWS before, we can start, stop, delete, do different things with this. If we go back to this resource group, we can see some other things. We can see the NIC if we wanted to see that, specifics. Again, kind of some of the same information that we already that we already had described before, and the security group that we looked at, which was allowing RDP 3389 from anywhere to anywhere and allowing anything outbound. So we have all of that. So here they say verify the records for this particular, the host that we just spun up are there. So let's go do that. So we see a test VM1 and test VM2 both have A records that were automatically assigned. The IP address shows you auto registered here. If we click into that, see the TTL is 10 seconds. And we can't modify this because we're using the auto registration. So here they want us to RDP into these. Okay, so if we're going to do that, we can go and RDP into this guy. This file is going to have IP address, port number. We're going to download the RDP file. Now I'm going to do this all behind the scenes. I'm not on a Windows machine, so I'm actually using Microsoft Remote Desktop application here on a Mac. So let's go over and make sure that we have the username and passwords correct from this. Let's test user and test password. All right, so this is prompting me for this. So we're going to go test user. I'm going to drop this in here. Continue. You might end up getting a warning message like this because using private certs on that or self-signed certs. So just go ahead and hit continue. All right, and now we have our test VM up. So we should be able to get into this. Just going to go down. Apologize if I'm cutting this off a little bit here, but we should be able to go down here to the bottom. Go CMD. Now, we should be able to do some resolution, but we won't be able to ping each other because we didn't actually put in anything in the network security group to allow ping. ipconfig /all. Let me see, this is going to be the self-assigned one for the host, but not actually what's going to be resolved from the DNS server. So if you remember, we go back and get the domain name or the host record for this, test VM1, ping test VM1. Getting a v6 address there. Let's try ping test vm1.cyberinsightlab.com. There we go. And that is .4. Remember when we were looking in the DNS records, that's what came back. So I'm pinging myself, so we're able to see that correctly. Now let's do the other VM. Now this is in the same subnet. And we aren't able to ping because I mentioned about the network security groups, but we are able to get the DNS resolution for that. So I think that does what we needed to do as far as setting that up and getting the auto registration within that VNet. So let's just go back and double check if there's anything else that we're missing here. If we see here the 20.4, 20.5, see if there's anything else going on. We open the command prompt, we're able to see that verify the IP address is what we noted. We pinged, we actually pinged both the FQDNs and everything was good. So that's some DNS basics in Azure right there. You've done it. So we created a private DNS zone. We added the name resolution and the auto registration link between the VNets. And then we spun up some VMs, which might have been the first time doing that within Azure using a little PowerShell and some JSON configs. And we were able to get name resolution going. So congratulations. Pretty cool. You can leave this lab just like this if you want to. If you did want to delete everything, let me just show you how you can do that if you don't want to wait to the next one. But if you do that, you might have to rebuild stuff. So if you want to actually get rid of everything, you can use this command here, this remove AZ resource group. All I did was went to the next lab that we're going to be doing, this exercise 3. So if you go remove AZ group name, the name of the resource group. So like in my case is CyberInsight Lab, and then -force as job, then you can do that. You could always just go delete those VMs if you want to do that. I think in this next one, we're probably going to be using those test VMs again. So yeah, just depends on what you want to do. If you got the free $200, then yeah, just keep it running. And I'm gonna get this other lab out later this week as well. So, all right, well, hope that was useful. Hopefully you enjoyed it. If you got any questions or comments, throw those down below. I'll hit those up. If you made it all the way to the end, make sure you smash the like button, subscribe to the channel, all that other good stuff, and we'll chat soon. All right, bye.